In today's math review, we'll be reviewing trigonometric functions. First thing we want to do is we want to cover the three basic trigonometric functions, which are sine theta, cosine theta, and tangent theta. What these are representing are they represent a ratio within a triangle. So if we draw a triangle, and define an angle theta, it can either be this angle theta or this angle. We just have to remain consistent throughout the problem. Define this as the adjacent side. Define this as the opposite side. And define this as the hypotenuse. The adjacent side will always be the side with the right angle closest to the angle theta, and the opposite side will be the side with the right angle furthest from the angle theta. The hypotenuse will be what is defined as the hypotenuse. Now there's a little phrase that we can use called Sohcahtoa. It's one of those things that will help you memorize things during a test if these things help you. So we have so, S-O-H, ka, C-A-H, toa, T-O-A. Now what this is representing is it's saying that the sine of the angle theta of this triangle is equal to O, the opposite, over the hypotenuse, H. Ka is the cosine of the angle theta is equal to the adjacent length over the length of the hypotenuse. And toa is the tangent of theta is equal to O, the opposite length, over the adjacent length. Now we can also, if you don't want to remember toa, we know that tangent theta is equal to sine theta over cosine theta. So if we put opposite over a hypotenuse and adjacent over hypotenuse, the hypotenuses cancel out and we end up with opposite over adjacent. Now what we're going to try to do is we're going to try to relate the angle theta to the ratio of either adjacent over opposite, adjacent over hypotenuse, and so on. So what we need to do is we need to figure out what the value of sine theta and cosine theta is if we know what the value of the angle theta is. So the first thing that we need to do in order to do this is construct what we call the unit circle. So what we're going to do is we're going to define a coordinate system, and define a circle within that coordinate system that has a radius of 1. So this is going to be positive 1 on the y-axis. This is going to be negative 1 on the x-axis, and this is going to be negative 1 on the y-axis. So this will have, if we define a line with a radius of 1, it can be at any angle around this circle, an angle theta, always measured from the positive x-axis. Now if we drop this line down, we notice that it intersects at what we're going to call x0, and intersects the y-axis at what we're going to call y0. So this is a coordinate point x0, comma, y0. Now if we notice right here, we kind of made a triangle. It has a hypotenuse of 1, and an adjacent side of x0, and a opposite side of y0. So we can define that we know sine theta is equal to opposite over hypotenuse. So we know the opposite is y0, and the hypotenuse is 1. So it's just going to be over 1. So the sine theta is equal to y0. The cosine of theta is equal to x0. And the tangent of theta is equal to y0 over x0. The next thing we're going to do is we're going to construct a unit circle for the most common angles that are used in trigonometry. So I've already pre-constructed it, and I'm going to paste it into our document right here. In this unit circle here, I'll review it, is we have the most common angles of 1/3 of an angle, 1/4 of an angle, and 2/3 of an angle, 2/3 of 90 degrees. So we're going to be using radians in trigonometry. So if we start here at 0 radians, we have pi over 2 radians here at what we would normally call 90 degrees, and pi radians at what we would normally call 180 degrees, and 3 pi over 2 radians at what we would normally call 270 degrees. Come back here to 2 pi. So an entire revolution around this circle is 2 pi radians. Once again, we also have a unit circle. So this is positive 1, comma 0. This is 0, comma positive 1, minus 1, comma 0, and 0, comma 1. So we have pi over 6, pi over 4, pi over 3, and so on as we go around the circle. Now these values here are the coordinate values for each one of these angles. So x0 for pi over 6 is square root of 3 over 2, and y0 is 1/2. Now these values, this drawing is something that might be helpful to memorize before a test where you would have to use this, and just draw it on your exam immediately before you start the exam. So if you have this, or you can just memorize this upper quadrant, the top right quadrant, which are all positive, and as we go around the circle, we adjust everything over here. The x values are going to be negative. Everything in this quadrant, both values are going to be negative, and in this quadrant, the y values are all going to be negative. Now we'll review what exactly this unit circle will help us with. So if we're asked to find the cosine of pi over 3, we know that, so if we go up and follow this circle pi over 3 radians, that brings us to this green line right here. Now we know that cosine theta is equal to x0. So if we just look at the value x0, we can very simply define pi over 3 as 1/2. Continue on the same kind of concept. The sine of 7 pi over 4, start at the positive x-axis, work our way around until we get 7 pi over 4. So that's this blue line right here. We know sine theta is equal to y0, so that's the second value. So sine of 7 pi over 4 is equal to minus 1 over the square root of 2. The tangent of, let's say, 5 pi over 6 is equal to fall to 5 pi over 6, we see that x0 is minus square root of 3 over 2, and y0 is 1/2, so we know it's y0 1/2 over x0 minus square root of 3 over 2, and this simplifies to minus 1 over the square root of 3. The next thing that gets us a little more complicated is that we're asked to find the cosine of 7 pi over 3. Now, if we know that this improper fraction here, 7 pi over 3, is greater than 2 pi, so this kind of doesn't fit our unit circle here because all of our angles are less than 2 pi. So we also know that each time we go around the circle, the next time around, the values x and y stay the same, even though the angle increases. So 7 pi over 3, so if we go around our circle once, that's the equivalent of 6 pi over 3. And if we continue to add pi over 3, this now, instead of pi over 3, becomes 7 pi over 3. So with 7 pi over 3 equal to pi over 3, our x0 is simply 1/2. Now, sometimes, possibly in another course, physics often uses degrees. So if we ask to find the sine of 45 degrees, we know that we have a relationship between degrees and radians. And that is, if we take our degrees, so sine 45 degrees, and multiply it by pi radians over 180 degrees. This is our unit conversion factor. So this part right here is equal to 1. So we're really not multiplying it by this anything but 1. And if we notice that degrees over degrees cancels out, so we'll end up with radians. If we plug this part into our calculator right here, we can find that sine of 45 degrees is the equivalent of sine of pi over 4, which we can simply find by coming along here to pi over 4, looking at y0, and seeing that it's 1 over the square root of 2. The next thing I'd like to review are all the trigonometric functions. Recently, we've only been using the 3 main trig functions, which are sine theta, cosine theta, and tangent theta. But there's also 3 more advanced trigonometric functions. And those are secant theta, cosecant theta, and cotangent theta. Now we know that tangent theta is equal to sine theta over cosine theta. Cosecant theta is 1 over sine theta. Secant theta is 1 over cosine theta. And cotangent theta is 1 over tangent theta, which is equal to cosine theta over sine theta. To do some example problems, if you're asked to find the cosecant of 5 pi over 6, what I'm going to do now is I'm going to pin up the unit circle. So we have the unit circle here, give us some space to work. We know that cosecant theta is 1 over sine theta. So if we look at So that's 1 over sine of 5 pi over 6, which is equal to, so if we look at 5 pi over 6, so we follow our unit circle to sine, so we look at sine, so that's 1/2. So we have 1 over 1/2, which is equal to 2. So the cosecant of 5 pi over 6 is equal to 2. We're asked to find the secant of pi over 3. Once again, we know that secant is 1 over cosine of pi over 3. So if we look at pi over 3, follow our unit circle, pi over 3 radians, look at cosine, that's 1/2. So 1 over 1/2 is equal to 2. So the secant of pi over 3 is equal to 2. The cotangent of 5 pi over 4 is equal to the cosine of 5 pi over 4 over the sine of 5 pi over 4. So we look at 5 pi over 4, follow our unit circle. It's down here to this blue one right here. So it's minus 1 over the square root of 2 over minus 1 over the square root of 2, which simplifies down to 1. The next thing I'd like to cover is one final example problem. So we're going to have a triangle, a right triangle. So one side, two sides, 3. We're going to define an angle theta. We have a right triangle, so this last angle is 90 minus theta. So we don't know the angle theta, but what we are given is we're given that this side has a length of 2. This side has also a length of 2. So in order to find the hypotenuse, what we have to do is we have to use the Pythagorean Theorem, which is a squared plus b squared equals c squared. So a and b are the two sides of the right angle, and c is the hypotenuse. So we have 2 squared plus 2 squared is equal to 8 is equal to c squared. So c is equal to the square root of 8, which is equal to 2 times the square root of 2. So this length here is 2 square root of 2. We're asked to find what the sine of theta is, the cosine of theta, tangent of theta, cosecant of theta, secant theta, and cotangent theta. We're also asked to find out what the angle theta is equal to. So if we look at sine theta, we know that sine theta is equal to opposite over hypotenuse. So 2 over 2 times the square root of 2. So that's equal to 1 over the square root of 2. Cosine of theta is equal to the adjacent angle, or the adjacent length over the hypotenuse. So 2 over 2 square root of 2 is also equal to 1 over the square root of 2. The tangent is equal to the opposite, 2, over the adjacent side, 2, which is equal to 1. The cosecant is 1 over sine theta. We already know that sine theta is equal to 1 over the square root of 2. So this is simply the square root of 2. Secant theta is 1 over cosine theta, which we already know is 1 over the square root of 2. So this is also the square root of 2. Cotangent is simply the cosine of theta over sine theta, which we know is 1 over the square root of 2 over 1 over the square root of 2, which is 1. So we have the answer to our 6 trigonometric functions, and now we need to find the angle theta. So the simplest way to do that is we could choose any one of these functions and match it to the unit circle. So I'm going to choose sine theta. So sine theta is equal to 1 over the square root of 2. So if I have this ratio, I have y0. And I just need to figure out where y0 occurs on our angle. So if we look at y0, no, here we go. 1 over the square root of 2. What angle is this? It's pi over 4. So in order for sine theta to equal to 1 over the square root of 2, sine must be equal to pi over 4. So theta is pi over 4. I hope this was a helpful trigonometric review, and I'll see you in our next tablet review.